Good morning children, how are you all? Welcome to another session of digital classes. In the last class we have studied about matter. Matter is something which has mass and occupies space. Everything what we see, we touch, we feel is matter. We have studied that matter exists in three forms: solid, liquid and gaseous. This matter is made up of tiny particles called as molecules. These molecules are made up of indivisible tiny particles called as atoms. So, let us get into the lesson: atoms, molecules and chemical reactions. So, let me ask you some questions before going into the topic. Children, does the weight of iron rod increase or decrease on rusting? What happens to magnesium on burning it in air? What happens to sulfur on burning it in air? Are the weights of reactants and products same or different? Think about these questions, children. Now, let us study about Anthony Lavoisier. He made many important contributions to chemistry and some call him as father of modern chemistry. He is Mr. Anthony Lavoisier. Children, he has proposed law of conservation of mass. According to law of conservation of mass, matter is neither created nor destroyed during any chemical reaction. The mass of products is equal to the mass of reactants in a chemical reactions. Before and after the reactions also, there is no change in the mass of any substance. Mass can neither be created nor be destroyed. So, mass of reactants is equal to the mass of products. Let us see one example which was done by Landolt. According to Landolt, when silver nitrate and hydrochloric acid react with each other, silver chloride and nitric acid are formed. He has taken two test tubes which were connected with each other, test tube A and test tube B. In test tube A, he has taken silver nitrate and in test tube B, he has taken hydrochloric acid. Now, you can see in this picture, they are not mixing with each other. So, he has found the weight of silver nitrate and hydrochloric acid before reacting with each other, and then afterwards when these test tubes were connected and when the reaction took place, silver chloride and nitric acid were formed, and now he observed that the weight of the products was equal to the weight of the reactants. So, this proves law of conservation of mass. Let us see one more example. Here in a conical flask, copper sulphate solution is taken and in the test tube barium chloride solution is taken. So, before the reaction takes place, the weight of the reactants were recorded and the weight of the reactants was 300.23 grams. You can see the test tube is placed inside the conical flask, the reactants are separate, so the reaction is not taking place. Now, after mixing with each other, what happens? The reactants will combine with each other, they react with each other and the products were formed, and barium sulphate along with sodium chloride is formed after mixing the two reactants, and when the weight of the products was considered, it was recorded as 300.23 grams, which was equal to the weight of the reactants. So, children, when barium chloride and copper sulphate react with each other, barium sulphate is a precipitate formed in a solution of sodium chloride. So, the weight of the reactants before the reaction is equal to the weight of the products after the reactions. This proves the law of conservation of mass. Children, let us come to the next law, law of constant proportion. This was proposed by Joseph Louis Proust. He is Mr. Joseph Louis Proust. he proposed law of definite proportions. He has taken a synthetic sample of copper carbonate and he found the weight of copper, carbon and oxygen separately in this synthetically prepared copper carbonate. That means this copper carbonate was prepared in the laboratory. So, he knows the amount of copper, carbon and oxygen present in this sample, and then he collected naturally present sample of copper carbonate, and then he has separated copper, carbon and oxygen and found the weight of them separately, and he noticed that the weight of copper, carbon and oxygen present in the synthetic sample and the natural sample were same. So, by this what did you understand, children? That the reactants, they combine in a fixed ratio, and then he proposed law of constant proportions. That means in a given chemical substance, the same element combines in a fixed proportions by mass. The relative proportion of elements in a compound is independent of the source or the method of preparation. In the earlier experiment we have taken naturally prepared sample and synthetically prepared sample, and we found that the same copper combined with a fixed amount of carbon and fixed amount of oxygen in a fixed ratio. So, the relative proportion of elements in a compound is independent of the source or the method of preparation. A given chemical substance always contains the same elements combined in a fixed proportions by mass. Children, why are these laws valid? Why do we need these laws actually? Why cannot the elements combine in any arbitrary proportions? Why should they combine in a fixed proportions? Because these elements, they combine together to form molecules. So, here we come with another theory given by John Dalton. John Dalton's atomic theory. John Dalton was an English school teacher. He proposed a basic theory about the nature of matter. Look at this picture. He is Mr. John Dalton. He said that all the atoms of the same element have identical mass and identical chemical properties. Atoms of different elements have different masses and they have different chemical properties. What did you understand, children? That every molecule present in a matter is made up of tiny particles called as atom. These atoms are different from one substance to another substance. So, atoms are not identical. So, children, atom is again made up of tiny particles. We will be studying about the subatomic particles present in the atom in the next class. So, this is the atom. It is again made up of tiny particles called electrons, protons and neutrons. So, children, when atoms of different elements combine in a different whole number of ratios, they form different compounds like carbon monoxide and carbon dioxide. Here in this example, if you observe carbon monoxide, that means it is made up of one atom of carbon and one atom of oxygen. So, carbon and oxygen, when they combine in a particular ratio, it forms carbon monoxide, and if it combines in another different ratio, it forms carbon dioxide. That means one atom of carbon combines with two atoms of oxygen. Here atom of carbon is different from atom of oxygen. They are not identical. They form compounds. Here we have taken a molecule of oxygen and two molecules of hydrogen. This is one molecule of hydrogen and this is another molecule of hydrogen. So, totally we have taken 2 molecules of hydrogen and 1 molecule of oxygen in reactants. When they combine with each other, what is formed here children? 2 water molecules are formed. Each water molecule, if you look at, it contains 1 atom of oxygen combined with 2 atoms of hydrogen. So, this is one water molecule and this is another water molecule. So, atoms are the building blocks of matter. It means that matter is composed of tiny particles known as atoms. These atoms are so small that we cannot see them even with the high powered microscope. Then matter contains large number of atoms. So, if you look at matter, as I told you, matter exists in 3 states: solids, liquids, gases. So, this matter contains very small tiny particles called as atoms, and these are the tiny subatomic particles present in the atoms. They are protons, electrons and neutrons. Atoms are the most fundamental particles. They can have an independent existence. Sometimes 2 or more atoms they combine to form a big particle called as molecules. Children, the particles of a substance contain only one type of atoms and then they form elements. And in elements, the smallest particle can be atom or a molecule. We will be seeing some examples, children. And there are many elements whose smallest particle is an atom, like iron, copper, zinc, aluminium, silver, gold, etc. So, here these are metals, they exist in the form of elements and they contain only one atom. So, they will be called as monoatomic particles. Here these are the inert gases: helium, neon, argon, krypton, xenon, radon. These elements, they do not combine with any other elements. So, they exist as atomic particles only. Oxygen and nitrogen are examples of substance in which the particles are a combination of 2 identical atoms. That means, they combine to form a diatomic element, a diatomic molecule. For example, see this picture children. Hydrogen, 2 atoms of hydrogen they combine to form H2 diatomic molecule. 2 atoms of nitrogen they combine to form a diatomic molecule. 2 atoms of oxygen they combine to form a diatomic oxygen molecule. 2 atoms of fluorine they combine to form a diatomic molecule. The same way Cl2, Br2, I2. In the earlier example we have seen inert gases, they do not combine with any other atom and so they exist in the form of same monoatomic gases because they are inert gases. We will be studying about it in the next class. Atoms of same elements or of different elements, they combine together to form molecules, and if atoms of different elements combine together, they form a new substance and that is known as compound. And a molecule can be defined as the smallest particle of a substance that has independent existence and it retains all the properties of that particular substance. So, let us see some examples children. Molecule can be element or a compound. Here in this example of hydrogen, it is a diatomic molecule. H2 is a element. So, H2 means diatomic molecule which contains 2 atoms of hydrogen, is nothing but a elemental form of hydrogen gas. And see the next example, CO2, that means carbon dioxide. It contains 1 atom of carbon, 2 atoms of oxygen, and here this molecule can be called as a compound. See some examples children. Water molecule, it contains 1 oxygen atom combined with 2 hydrogen atoms. And look at the next example. Here ammonia is a molecule, it exists in the form of a compound. In this example you can see 1 nitrogen atom combines with 3 hydrogen atoms, and the same way carbon dioxide and hydrogen peroxide. Hydrogen peroxide is a compound which is made up of 2 atoms of oxygen and 2 atoms of hydrogen. So, why do we name elements, children? First of all, going into the chemical reactions, first of all let us know what is the necessity of naming elements, so that we can name a compound and then we can name a matter, isn't it, children? But what is an element? Element cannot be again divided into, further it cannot be divided by a physical method or a chemical method into simpler forms, because element is nothing but made up of similar atoms of same element. So, it can be diatomic molecule, or it can be a tetraatomic molecule like P4, or it can be octatomic molecule like S8. 8 atoms of sulfur, they combine to form sulfur molecule. S8, though it is formed by the combination of 8 atoms of sulfur, it is an element of sulfur. So, we have to write the symbols of elements, because if you are writing a compound like for example sodium chloride, and in any chemical reaction if you are writing about sodium chloride, if you do not have a particular symbol, then we write SODIUMCHLORIDE, sodium chloride, the whole name, isn't it? So, it is better that we write symbols for every element, and these elements when they combine with each other to form a compound or a molecule, they can be written in the form of a chemical formula. So, first let us study about the rules of writing symbols of elements, so that we can learn how to write the chemical formula of a chemical compound. So, children, John Berzelius suggested that the first letter of element from its name in the English written in capitals will be the symbol of that element. So, he is John Berzelius. He has given us the rules to write the symbols of elements. First letter can be written as the symbol of that element, and if you have 2 elements with the same letter in the starting, like for example you have sulfur and sodium. Sulfur starts with S, sodium starts with S. Then you can't write S for sulfur also and S for sodium also, because you will be confused. So, the second rule what we have to follow is take the first letter and the second letter, but here you have to remember that the first letter should be capital and the second letter should be written in the small form. So, see children, a symbol can have either 1 or 2 letters of English. The first letter of the symbol should be in the uppercase and the second letter should be in the lower case. For example, helium, the symbol of helium is taken as the first letter H and the second letter E, He. Beryllium, first letter B and the second letter E is written, Be is the symbol of beryllium. So, these are the symbols of some elements given. The symbol of hydrogen is H, symbol of oxygen is O, symbol of nitrogen is N, symbol of sulfur is S, symbol of carbon is C. And children, if you consider boron and barium, both are starting with B. So, the symbol of boron is B and the symbol of barium, if you see first letter and second letter we have taken. So, symbol of barium is capital B and small a. And if you look at this iron, the symbol of iron here is Fe and symbol of gold is Au and symbol of sodium is Na. Again there is another rule followed, some unusual symbols. We observe that the symbols for some elements come from their names, but some do not. Instead of writing the old names, the symbols of these elements are written from the Latin names of the elements. Let us see some examples of some elements with their Latin names and symbols. Children, sodium, the Latin name of sodium is natrium. So, what will be the symbol of natrium? Na, capital N and small a. Silver, the Latin name of silver is argentum, symbol is capital A and small g. Here this is another rule of writing the symbol, children. Here in argentum, if you take the first letter and the second letter of the name, then it will be AR. AR is the symbol of argon. So, you cannot take the first letter and second letter for argentum, and so we have taken first letter and the third letter. First letter is A and the third letter is G, and so we have taken capital A and small g. So, Ag is the symbol of silver. Tungsten, the Latin name of tungsten is wolfram and the symbol is capital W. The Latin name of potassium is kalium, the symbol is K. Like this, these are all the names of some elements given, and these are the symbols of these elements. Elements with more than one atom in their molecules. Several elements have more than one atom in their smallest constituent particles. Then, while writing the formula of elements with more than one atoms, then how are you going to write? We have to indicate their number. So, first you have to write the symbol and then write the number of atoms as a subscript. Every molecule of oxygen has 2 atoms. So, the formula of oxygen molecule is O2. This O is a symbol of oxygen atom. It is made up of 2 atoms of oxygen. So, the formula of oxygen molecule is O2. Every molecule of ozone, it contains 3 atoms of oxygen. So, we write it as the chemical formula of oxygen is O3. Coming to the next topic, atomicity. Atomicity indicates the number of atoms present in the molecules. For example, the number of atoms present in oxygen we have seen is 2. So, atomicity of oxygen is 2. He, helium we have seen, it is made up of 1 atom of helium. H2 we have seen, it is made up of 2 atoms of hydrogen. So, atomicity of hydrogen is 2. Atomicity of oxygen is 2. Cl2, chlorine molecule, the atomicity of chlorine is 2. O3, ozone, S8 as I was telling you. Here 8 atoms of sulfur atoms. So, here 8 atoms of sulfur have combined to form an elemental form of sulfur. So, we write the chemical formula of sulfur as S8. Here the atomicity is 8. A molecule of hydrogen contains 2 atoms of hydrogen. So, it is called as diatomic molecule. Whereas, helium, argon, as I told you, they exist as single atom. So, such atoms are called as monoatomic molecules. Here these are the atomicity, children. Helium, only 1 atom, so we call it as monoatomic. Iron, 1 atom of iron is present in the element of iron, so we call it as monoatomic. N2, nitrogen. So, here the nitrogen molecule is made up of 2 atoms, so we call it as diatomic. Ozone, if you see, the chemical formula of ozone is O3. Here it is triatomic. Phosphorus P4, tetraatomic. Sulfur S8, 8 atoms of sulfur, they combine together to form the element of sulfur, so we call it as octaatomic. So, atomicity of sulfur here is 8. Why are some elements monoatomic, children, and why are some elements diatomic or triatomic? Why do other elements have different atomicities? Because of valency. Valency is the combining capacity of a particular element, and it differs from one atom to another atom. Children, the atomicity of a molecule depends upon valency. Valency is nothing but the combining capacity of element. Every element reacts with each other in an other element according to the combining capacity. What is it called as? It is called as valency. Valency of different atoms are different. For example, helium, as I told you, it will not combine with any other element because it does not want to lose electrons or it does not want to gain electrons. So, it has a valency that is 0. That means, it is not going to combine with any other element, as valency is the combining capacity of atom. Here hydrogen valency is 1 because it has only 1 electron and it wants another electron to become stable like helium. So, it is going to share 1 more electron. So, here the valency of hydrogen is considered as 1. Valency of fluorine is 1, chlorine is 1, oxygen is 2, nitrogen is 3 and carbon is 4. There were many definitions which were given for this valency, children. Some definitions are, for metals we have seen it is nothing but the number of electrons present in the outermost shell of a particular metal. And then for non-metals they have given it is the number of electrons they want to share with another non-metallic element. And then valency is also the number of hydrogen atoms with which it can combine. And one more definition given was, valency of any element is the number of chlorine atoms it can combine with, or the valency of an element can be stated as double the number of oxygen atoms it can combine with. So, these are all the definitions given for valency. So, we have to learn about valency in detail. Let us first go to the next topic, that is ion. What is ion? Elements are of three types: metals, non-metals and metalloids. So, metals, they lose electrons to become stable like inert gases. We have seen inert gases, that means they are inert, they are noble gases, they do not combine with any other element like helium, neon, argon, krypton, xenon, radon. So, these metals, they lose electrons to become stable like inert gases. When they are losing electrons, they are acquiring positive charges, and now they are not called as atoms. Atoms, when they lose electrons, they become positively charged ions. Children, what is an ion? The compounds formed by metals and non-metals, they contain charged particles. So, I was telling you, metals, they lose electrons to form positively charged, then as they are losing electrons, there should be somebody else to take the electrons. Who is taking? Non-metals. Non-metals, they take the electrons and they acquire a negative charge. And then a positively charged metal ion and a negatively charged non-metal ion, they combine together to form a salt molecule or a compound. So, children, the charged particles are known as ions. Here, if you consider hydrogen, oxygen and magnesium, these are all atoms, and water molecule, that means H2O is a molecule. But if you consider Mg+2, here Mg+2 means magnesium atom has lost 2 electrons. So, this is an example of magnesium positively charged ion, and here this is an example of negatively charged hydroxide ion. Here oxygen is combined only with one hydrogen. What happened to the other hydrogen? It was removed, and now this gains a negatively charged. So, hydroxide ion, we call it the OH- ion. So, ions may be charged, they are independent atoms or group of atoms, that means atomic atoms. Just now we have seen OH- ion. Here these ions are called as charged particles. Some more examples of ions, children: sodium chloride, if it is dissolved in water, it splits into Na plus ion and Cl minus ion. Sodium lost electron and it forms sodium positively charged ion, and chloride ion is formed as a chlorine atom has gained a negatively charged electron from sodium, and now it is called as chloride ion. It cannot be called as chlorine atom. Chlorine atom has gained an electron which is given by sodium ion. So, look at this example, children. Sodium has lost 1 electron. So, in this example, if you see, sodium has lost 1 electron and forms sodium positively charged, and chlorine has gained 1 electron forming a negatively charged chloride ion. So, these are all the examples of ions, children. Look at your textbook and please learn how to write the symbols of these ions. So, how are we going to write the molecules of the compound, children? As I told you, a molecule is formed by the combination of atoms of same element or different elements. So, here we have written the formula of water H2O, and we have written the molecular formula of carbon dioxide CO2, and molecular formula of NH3 is, children, this is water molecule, 1 atom of oxygen with 2 atoms of hydrogen. This is carbon dioxide, 1 atom of carbon and 2 atoms of oxygen. This is ammonia molecule, 1 atom of nitrogen and 3 atoms of. So, children, we will be studying about the rules for writing the chemical formula in the next class. We use crisscross method of writing the chemical formula, and the very important thing what we have to learn is about valency. So, please learn about valency and the chemical formula of ions, so that it will be easy for us to learn how to write the molecular formula of a particular compound. Okay, children. So, let us revise what we have studied. In what we have learnt, we have studied about law of conservation of mass, we have studied about law of constant proportion, we have studied about molecules, atoms, we have studied about the symbols of how to write the symbol of an element. So, answer these questions, children. Explain the process and precautions in verifying the law of conservation of mass. Please download the worksheets from SIET for better learning and good practice. Okay, children, see you in another interesting session of digital classes. Thank you.